In the previous videos, we had seen how we can do interprocess communication using pipes and FIFO. So in this video, we are going to learn how we can do IPC using System5MQ. So System5MQ is basically System5 message queue, which is a classic message queue which is available across Unix and all its successors and its related systems. Okay, so it is present on Linux as well. And another one is the POSIX-MQ, okay, which is the modern version of the message queue family. Okay, so POSIX-MQ is based on a standard and it has like inbuilt threading in it. Okay, so it is thread safe, you can say, and there are different types of options for it. Okay, and in today's video we are going to be only focused on the System5 message queue. Okay, so in the next video we might see the POSIX-MQ. So we'll have the discussion about POSIX-MQ in that video, and then we can do a cross comparison between System5 message queues and POSIX message queue. Okay, so first we'll start writing the sender for this message queue. Okay, so sender sys5 will have a file over here, sys5.c. okay, so once we create this file, we'll include our standard headers, okay, like stdio and stdlib. Okay, so and we'll be using string.h as well. Okay, because here in message queue we are going to send a message through the sender to the receiver, so that string copying and stuff will be required, so we'll be using string.h. okay, and now the important headers are sys/IPC. okay, so this is the important header which will be used for like the message get function, okay, which will create the message queue for us. It will give us the message queues you call ID over here. Okay, that will be in the sys/IPC. okay, second file we'll need, header file, is sys/MSG, which will have the message directives. Okay, send, receive and all those things will be a part of this. Okay, and one more file will be required, we have is sys/types.h. okay, so types.h is also an important file because for this MQ we basically require a key to be generated. Okay, a unique key to be generated, and that key is used to create an IPC channel, you can say, and then on that channel we send the messages. Okay, and here the messages which are sent from System5 message queue have something called as a message ID. Okay, so based on that, or you can say message type ID, based on that you can bifurcate the messages. Okay, so we'll see how we can do that. So we'll include #include or no.h as well, which will give us error handling stuff. Okay, and now we'll first create a struct for the message part. Okay, so struct msgbuff, which is the message buffer. Okay, so this will have basically two things. One is this mtype, which is the message type. Okay, so this is usually used as an identifier in the receive function. Okay, and here we'll have the literal message we want. Okay, so here we'll create that part. Okay, so here we have created the message buffer for this thing. After this we'll write the main function. So first thing is we have to create a key over here. Okay, so here we are creating a key. After that we'll have a message queue ID. Okay, so we'll call it message queue ID, which will create a message queue variable which will be storing here. Okay, and now here we'll take the instance variable of this thing. Okay, sorry, msgbuff, and we'll call it message. Okay, and here, like I said, first we need to create a key. Okay, so for that we have created a variable key. Okay, and here to create that key we use a function ftoc. Okay, so this is a very common function that we'll be using. So this will require a path. Okay, so path rules are like you need to have a front slash in this name, and you can have anything, but like you cannot use two front slashes, okay, or it cannot end with a you could say not two front slashes, but it should not end with a front slash, okay. So it should be a file name, not a path, okay. So here, so it is named path name, but again if you end it with a front slash, okay, if your path ends with a front slash, then you will get an error, okay. So here this is the one part we do, and second one is a project ID. Here we are going to give the project ID as A, okay. So project ID could be any integer basically. So we are giving A because it has a ASCII value of 65. So usually it is a common known notation for this thing, okay. So after that we have to check whether actually key was generated or not. So for that we will use key response. We will use what we got. If we got a key as -1, then there's definitely something wrong with that, and here we throw an error, okay. So we got this error in ftalk, so we write error ftalk and exit 1. Exit 1 will give us like non-graceful exit, okay. So now that we have created this thing, okay, now we need to, first we have created the key. Now second step is to create this message queue, okay. So to create a message queue we use something called as message get function. Okay, so here we'll be creating this message queue, okay. So whether even if this function is called message get, it will not literally get the messages, okay. So message get is basically get a message queue, okay. So do not get confused with the name of this function, okay. For receiving messages there is a different function called msgrcv, which is message receive. So this doesn't get the messages, it will create or get a message queue for you, okay. So yeah, and key parameter, and second is the flag, or you could say creation flag for this thing. So we'll create IPC create, okay, for this thing, and we'll give it a read write permission for all three cohorts, okay. And after we create this message queue or get the message queue, basically we'll check whether we literally got some message queue or not, okay. And if we had some error, just like previously done, we'll do it again. We'll just write here p error, and then we write msg get, and we write exit 1, okay. So here we created the message queue. Now the important step is to create the literal message, okay. So here we have taken the same variable that we created over here. So here I created this variable message, okay. So here first thing I will set is the type, okay. So type you can use any number, but you need to remember that you use this same number in the receiver part as well, or you could use equals to 0 in the receiver. So if you use 0, then it will take all types of messages, okay. So this is just for a segregation of messages, so this thing doesn't really affect the little, what you call, the content or the payload of the message, okay. So payload is separately in this part, okay. So for the payload part, what we'll do is we'll do string copy function, okay. So for the payload we have message dot mtext, okay, and test message, okay. Sorry, okay. So we wrote our message. Now the important part is to actually send the message. So here to send the message we use the msg send function, and this function also, first parameter is the queue id, okay. So the id that we just created, which is msg queue id. Second parameter is the size of the message, okay. Sorry, second parameter is the message, literal message, not the size of the message. So here we pass the pointer to that message, okay. Sorry, third parameter is the size of that message. So we do size of for the whole message thing, okay. For the whole message thing, you understood what I meant by the whole message thing. So it is basically the text part, okay. so will not take the what do you call the ID or the what do you call the identifier, the text M type will not take that part, will just take the text, okay, for the size of. And finally this is the message flag, which you can pass 0 for now, okay. So there are other things also you can pass over here, but for now we'll not get into that discussion, okay. So this flag you could pass different types of messages depending upon how you want to process the messages. Do you want to do it in a blocking way, non-blocking way, or different types of mechanisms you can use for that? So that is why we have this last part, okay, which is the flag, okay. So it will have like no weight and all those things are there, so that is a long discussion, so we'll avoid that part. So here, if our message is successfully sent, okay, so what we could do is, if the message gets any error and it returns -1, then again we can write p error msg get, okay. So just to denote like where you got the error exactly, and again exit 1. And now once you send this message, okay, you can return 0. So this was for the sender part, okay. So now we'll see the receiver as well, okay. So for the receiver also we have kept the script, okay. So for this sender part, let me just compile and check whether I have written it properly or not. GCC sender sys5 okay. So it got compiled properly, okay. So now the receiver part, okay. So for the receiver also we can use the same template, okay. So receiver sys5.c. So for the receiver part also we can use the same template, okay. So we'll copy this template as is, okay. Simply write this, okay. So the receiver also we can use the same logic, okay. The only difference here is we will not do the IPC create over here, okay. This part we will remove, and secondly here we will change the function of this thing, okay. So there we had message send, okay. So this part will go away, okay. So it will not be entering that part, okay. So here what we will do is, instead of this part we'll replace this part, okay. So here what we'll do is msg rcb, okay. And here if you see, again the first parameter will be the message queue id, okay. Second parameter again the message, here the message variable will be getting the message, okay. So that is the part that changes over here. Now after that the other parameters, that is the size of and all those parts, they remain the same, okay. So one extra parameter we have in this case, okay, if you see carefully the data that is hovering over there, one is the message type part, okay. So first we will put the size, okay, sorry, size of this thing, message dot m text, okay. After that we will have type. So here we will have the type at 0. 0 will get all the messages, okay. If you add a specific number over here like 1 or -1 or any sort of number, then it will get only that specific type of message with that message type, okay. So that, like I said, it is for the bifurcation part, okay. And finally 0 for the flag again, okay. And here what I will do is I will check if there are any errors, then it will return -1, and in that case you will have to do p error msg receive, okay, and exit 1, Now that you have received the message, okay, so what we will do is we'll just simply use printf for that part. Once if you successfully get the message over here, what we'll do is we'll do printf for the message. So we write backslash received message, okay, and here we write %s and backslash n for that new line after it, and here we write message dot mtext. Okay, so once this is done, this will show the message. But now we have just displayed the message, but like I said, this will remain at a zombie resource in your system if you don't clear this queue. Okay, so usually it is advisable, like before exiting your application, you should clear the queues or you should delete the queues. So for that, what we need to do is there is something called as message CTL or message control. There you have to pass, like always, the message queue ID, okay, msg queue ID. Second parameter is operation, okay, that is IPC RMID, which will remove the message queue. And third parameter in this case will be null, because it is not any operation that requires any parameters, so that is why it will be null. Okay, and like always, this also will be checked if there are any errors or not. Okay, and if there are any errors, then you will have to do a p error for this thing and write msgctl exit 1. Okay, and yeah, finally we can see. Let's just reiterate if we have done everything properly. See here, everything remains same over here, nothing changes. Okay, similar way we have to use this thing. Okay, only difference, like I said here, is you will not use IPC create over here, so you have to use it in either of the cases. Okay, so if you are doing it in sender, don't do it in receiver. If you are doing it in receiver, if you are creating the receiver, from the receiver you are creating the queue, then don't write in the sender. Okay, so that is one thing that you need to remember. Now that we have written our code, let's just try to compile this thing. Receiver sys5.o sys5. Okay, so we have run this part. Okay, we'll just compile this again. Okay, open two terminals over here. In one terminal I will start the receiver, and other terminal I will start the sender. So here, if I start the receiver first, because I have not created anything in the receiver. Okay, so what happens if I start the receiver first? Let's just see, it will give us an error. Okay, it will say it hasn't got any no such file or directory, it will say. Okay, so now what we need to do here is we need to start the sender first, because like I said, we created the sender, we created the message queue in the sender. Okay, so we have to run that part first. So here sender has sent the message. Now when I click it, it will show the message. So here it was our message, that was test message. If you see properly, see here we have written the message, test message. So if I change this, test message 1 2 3 4 5. Okay, and here if I recompile my sender, because the receiver doesn't need recompiling in this case. Okay, and now when I send this thing again, see here, I have sent it again, and now when I receive, see here, test message 1 2 3 4 5. So this is how sys5 message queue works. Okay, so here, like, the basic steps are like, first you create a key for this thing, generate a key, okay, using ftalk. Okay, secondly you create the message queue itself, IPC queue. Okay, after creation of the message queue using msg get, then you write your function msg send or msg receive. Okay, So that is general criteria, or you could say general steps that you need to follow over here. And finally, once you are done with this, you can clear the IPC queue, or you can delete it using message control or MSGCTL along with the IPC RMID option. Okay, so I hope that was helpful for you guys. Thank you.